All right, so we're going to do one regression problem, and I'm going to review some linear regression in it. Let's get started. The Earth's moon has many impact craters that were created when the inner solar system was subjected to heavy bombardment of small celestial bodies. Scientists studied 11 impact craters on the moon to determine whether there was any relationship between the age of the craters based on radioactive dating of lunar rocks and the impact rate as deduced from the density of the craters. The data are displayed in the scatter plot below. Okay, so when we look down at it, we see our x here is age. This is our explanatory variable. Okay, and then here's our response, impact rate. The first question says, describe the nature of the relationship between impact rate and age. When in doubt, we're always doing SUDS and a basic conclude. You look at this and you see, okay, this SUDS is shape, so this is very curved. Okay, so the relationship between, I'm going to type, actually a little faster. The relationship between, give me a second. Okay, so describing, I'm doing SUDS and I'm doing a basic conclude. So I'm going to say the relationship between age and impact rates is curved. So that's this S. The U would be, is there anything unexpected? Okay, so there's nothing really unexpected. We have a pretty strong relationship here. And how do I know it's a strong relationship? Because it's curved. Something unexpected would look like something out here or something way down here. There'd be a huge gap. We do have some gaps right here. So you could say maybe there's a potential outlier here. You could speculate on that and you wouldn't get it wrong. And in fact, when I circle it and I look at it, you can see if I took those away, the relationship would be much straighter. Okay. So either way you can get credit. So we can say those are two unexpected points or not. But the big thing is you say that it's curved right here. All right. Hopefully we're good. The relationship between age and impact rate is curved with no with nothing unexpected. It is a strong relationship. It is a strong negative relationship. So this took care of the shape, anything unexpected, the direction, and the strength. SUDS. Remember, the strength is that oval test. How tight is the oval? And that oval is very tight, and that's why we say it's strong. Okay. Then we're going to just put a basic conclude statement. As age increases, we're going to say it appears that impact rate goes down. Okay, so prior to fitting a linear regression model, the researchers transformed both impact rate and age by using logarithms. The following computer output and residual plot were produced. So just as a reminder, we see that we have our y-intercept right here. We have our slope right here. This is the standard deviation of the residuals. You need to know how to interpret all of those, okay? We also have our r squared right here. You need to know how to interpret that. If you're dealing with any kind of inference, here's your standard error. Now remember, they've already divided by the square root of n there. So if you're going to do an interval, you would take your if you're going to make an interval for the true slope, you take your slope right here, plus or minus a t star with the degrees of freedom that you're dealing with, times your standard error to get your interval. If you need to get your, if you're doing a test, here's your t-score right here. And here's your p-value, okay? At this point, while you're watching the video, write down anything, questions that you might have, or anything you want me to cover further just about all of these numbers. Other than that, I'm going to go ahead and I'm going to finish this question. Okay, so we have our residual plot, and we can see here that it does it doesn't look the best. I would say there is a slight U in it. You can see. Hopefully that makes sense. Moving on to the question, it says interpret the value of r squared. So I'm going to take that r squared, and that r squared is 89.4. And I'm going to type it out so it goes a little faster and it looks cleaner. I'm going to say 89.4% is the fraction of variation in y. Okay, so what is y? The biggest thing is it is not the impact anymore. It is the log of the impact, because they took the logarithm of both sides. And you can see here, what kind of log did they take? They took the natural log, because there's the regression equation. Okay, so I have it memorized again, and the only thing that's going to change now is 89.4% is the fraction of variation in y. So what does that mean? I'm going to say the natural log of impact rate that can be accounted for by the least squares regression line of the log of impact rate on the log of age. Write down any questions. So at the very minimum, you need to have the definition of r squared memorized and be able to just fill in, hey, here is my y, here is my y, and here is my x, and just be able to fill that in. That's the very minimum. I'll try to post another video really truly explaining the background of r squared later if we need to. Part C says comment on the appropriateness of the linear regression for modeling the relationship between the transformed variables. So I'm looking at this residual plot and I still see a U. It doesn't look that great to me. We should have equal scatter above and below the line. So if I added those points, that would look much more appropriate to me. So how am I going to write this down? All I'm going to say, and here's a hint on the AP test, is you want to use their wording to just kind of help you. So you'd say, comment on the appropriateness of the linear regression for modeling the relationship between the transformed variables. So I would say, the linear regression for modeling the relationship between the transformed variables, so I'm just reusing what they said, is not appropriate because there appears to be a pattern in the residual plot. All right.